Welcome to Speaking Concretely, the official podcast of the Cement Association of Canada. I'm your host, Adam Auer, President and CEO of the CAC. Today I'm joined by Apoorv Sinha, CEO of Carbon Upcycling. Carbon Upcycling is a waste and carbon utilization technology company unlocking a new frontier of circular materials and one with particular promise for improving both the productivity and carbon footprint of the cement and concrete sector. Apoorv started Carbon Upcycling in 2014, and the company has since grown into a leader in the clean tech space. Apoorv, welcome, and thanks so much for joining us today.
Thanks so much for having me, Adam.
Why don't we start with you just telling us a bit more about carbon upcycling and its technology?
Yeah, Adam, we started carbon upcycling back in 2014 with an idea of making carbon emissions from industrial emission sources such as, flue gas stacks at industrial power plants, energy plants, and cement and steel plants, and basically converting those carbon emissions into valuable solid products. And the way we were going about doing this is what we call a semi-dry mineralization technology. We refer to it as MACE, or mechanically assisted chemical exfoliation. But basically the whole premise behind this idea was always that if you look at a lot of the way the CO2 is stored outside the atmosphere, we're usually storing it in oceans, or it's getting weathered into rocks. And almost all of this chemistry requires us to have aqueous chemistry, meaning you need to have water as kind of an intermediary to capture the CO2, make a bicarbonate ion, and then make it into, a solid rock or make it into corals and things like that. In our case, our core technology was around how do we achieve this in a solid gas interaction as opposed to requiring inordinate amounts of liquid or water to facilitate this chemistry. And that's really where we built up a lot of our core IP. In the beginning, for the first 6 years of our existence, we were really focused on carbon-based nanomaterials, such as graphene. And our thought was that we'd be able to make these nanomaterials that are derived from CO2 and then use those in advanced polymer composites or energy storage. And we did that for a few years, but realized that if we really wanted to have the climate and the CO2 impact that we wanted, we had to go after an industry that had a much bigger climate impact to begin with. And that's kind of what led us around 2019, 2020 towards the cement industry. And what we realized then was that we could tailor this solid gas chemistry that we've been working on to the inorganic chemistry of making cement. And it had a particular advantage for the cement industry because all of the work that happens in making cement out of limestone and other process additions is happening in a dry form anyway. So the advantage of dealing only with solids and gases was something that we found to be a really good fit in that industry, and hence where we are today.
We'll get to the cement and concrete industry in just a bit, but starting a clean tech company is definitely not for the faint of heart. And I was hoping you could just share a little bit what inspired you to take on that challenge. And now that you're about 10 years in, what are your reflections on building a clean tech company from the ground up?
Quite a few reflections, Adam, but what I would say is, the initial kind of motivation to get started with carbon upcycling was definitely technically driven. I was a chemical engineer in my training, and one of the things that I really found a lot of personal interest and motivation in was to try to solve technical problems that actually had the potential to have material impact in the real world. And so I think that was ultimately what drove me to this. And working at Carbon Upcycling, we had, me and a co-founder had also started a humanitarian logistics startup before Carbon Upcycling. And, so I had always kind of wanted to see if we could use some of the stuff we learned back in school in a way that could actually help people. I think with Carbon Upcycling, initially the thought was that we'd be solving a problem that would help the frontier industries, with advanced composites and energy storage and those kind of places, which sound really exciting and could have a material impact in a lot of the energy transition that we're seeing. But over time, what we realized is, if we look at just the raw numbers of impact that the building material sector, the steel sector, the fertilizer sector have, these heavy industries may not be at the leading edge of, what you read about on the technology section of a newspaper, but they make massive amounts of not just carbon emissions, but economic activity that helps our industries go forward and civilizational progress. And so over the last 6 years, I think there's been an understanding that we have a very key role to play in that. And I think that's been further kind of a point of motivation for me. But I would say with regards to the reflection piece, I definitely didn't appreciate just how challenging, running a startup can be. And I think you always kind of, forget just how long time can take, like how long things can take to happen. And so I think given that, I think the biggest lesson that I've reflected on recently is the importance of not just looking at the technical aspects of a technology or a solution, but actually looking at the people and the holistic aspect of how this solution might get fit into an ecosystem of players that already exists. And I think, honoring those relationships, making sure that we're taking a collaborative approach to getting this technical solution out into the field, I think has been probably something that I was neglectful of in the past, but have tried to be a lot more, mindful of as we've charted our path in the last couple of years.
Well, let's talk about your success. I mean, I've been watching your company grow over the past number of years. You've got a much larger staff, obviously, than when you started, and your production capacity has also increased. I think from your website, it suggests that you started with about 250 grams of material being produced every year, and now somewhere north of 17,000 tons of that material being produced every year. Can you put that into perspective for us? Is this sort of where you expect it to be in terms of your growth, and what does that production capacity look like in the future?
Yeah, Adam, I still recall quite vividly, the first reactor run that we did back at the University of Calgary. So we didn't spin out of the university, but we're always engaged with them because we couldn't afford a lot of the characterization equipment that you needed. So we would get our reactors kind of set up at the university and do all of the analytical chemistry work there. And this was in early 2015. And actually October 2014 was when we did our first run. But the first set of runs where we actually started to replicate our work was in early 2015. And I still recall vividly that I think our batch sizes at the time were about 1.5 to 2 grams every run. And we would have to run them for 12 to 24 hours and then, kind of wait anxiously about kind of what the results showed us about CO2 uptake or, the final performance of the material in some of the applications that we're looking at. I think to your point, when we fast forward now to look at the couple of units that we've got, the commercial demonstration units that we have in Western Canada, in Calgary, it definitely feels, a lifetime away from where we started. But, as you know better than anybody, we're nowhere close to making a dent in the carbon impact of cement yet. Overall, even kind of if I look into the near future here, we're going to be deploying a 25,000 ton a year facility in Eastern Canada, in just outside of Toronto in Mississauga. That facility is expected to come online by the February or March of next year, so of 2026. And that facility will be making up to 34,000 tons a year. And our thinking is in the first couple of years, they'll probably do 25 or so. And that is going to be really our kind of most exciting step so far. I mean, we've had a lot of progress in terms of scale up to date, but what really excites us about this next step is this will be the first time that we'll be fully integrated into an operating cement plant with our partner CRH, and actually showing that this, cementitious material production with CO2 and a local kind of low grade material like steel slag can actually create a cementitious material that people can blend into their cements and show not just the environmental performance, but also the technical performance of the product. And so showing all of that in a commercial demonstration field is exciting, like, being able to do that at test centers, but to actually show it at an industrial scale for us will be kind of the key unlock to then be able to start hopefully replicating that in many other projects and cement plants across the world.
I want to get into the details, if we can, of the project that you just mentioned with CRH or Ashgrove Cement in Ontario. But I want to explore this concept of scalability, because you mentioned going after the materials industry in part because of the size of its impact. And as we've said on this podcast a number of times, concrete is the most consumed material on the planet after water. I mean, the scale is enormous. And when you talk about clean tech, often one of the major challenges that you hear about is that challenge of scalability. What does scalability actually mean in the context of carbon upcycling, and in particular in the context of reducing emissions from the cement and concrete industry? We talked about material substitution. If you look at our decarbonization roadmap, we talk about supplementary cementitious materials and trying to get the ratio of that carbon intensive clinker down. I mean, you fit very squarely into that space. So explain to the audience a little bit about the potential, the scalability, how carbon upcycling is kind of playing into that space.
Yeah, Adam, and I'm sure many of your listeners will already be aware of kind of the context of kind of what the cement industry needs to do to decarbonize. But just at a very high level, the three levers that we've seen, and obviously the CAC has written about, the three levers that many of these companies have identified are alternative fuels, alternative raw materials or material substitutions, and carbon capture and storage. And generally, what we have found is that the carbon upcycling technology, or how it kind of pertains to the cement industry, we're really kind of focused on taking locally available solid kind of byproducts of other processes. These could be steel slags, they could be low-grade coal combustion ashes, they could be mine tailings. And essentially what we've been focused on is taking these materials that may not always be available near a cement plant, but there's a very strong likelihood that you'll have at least one of them available near any given cement plant in the world. And the idea is that if you can activate these materials while using some of the carbon from your flue gas stack, from your clinker production, you've actually created a symbiotic relationship that not only allows you to get some direct sequestration of CO2, but to your point about material substitutions, allows you to ultimately get a material, an activated SCM or supplementary cementitious material that you can blend in with your cement to make a lower carbon footprint at the end. And so what we have found with our testing so far, Adam, is, if you work with some of the steel slags that we've activated, you could reduce clinker by 20 to 30% based on the strength activity that you get with the blended product. With other materials, like with low-grade combustion ashes that we've been able to upcycle, or with many clays that we've been able to mechanochemically activate, we're seeing upwards of 30% of substitution. In some cases, if you mix it in with other fillers like limestone, you might be able to get to a clinker factor of less than 50%. And so when you add all of that up, I think what we have really focused on is how do we create a solution that scales with the volume of how much cement we produce. To your point, almost 3 billion tons of cement every year is produced around the world. And a general cement plant in North America is going to produce 3,000 to 4,000 tons of cement a day. And so if you don't have feedstocks that are available in that kind of quantity and cheaply, you almost inherently cannot scale to meet the demand that the cement industry has. So that has been a big focus of ours. And we found with slags and with mine tailings, with clays, with coal combustion ashes, that you do have repositories of these materials that are commensurate with limestone deposits that many of these cement companies have access to. So that, I think, is number one of kind of what we look at with scale, because if you don't have enough of the raw material, there's almost no way you're going to make enough of the final product that the industry needs to get out. But then the second piece, I think, is how you integrate into the supply chain. And because we have this dry or semi-dry solid gas chemistry, we're able to plug our technology in right at the cement plant. And, generally the cement industry and the concrete industry kind of works in a hub and spoke kind of fashion, where you've got one major centralized cement plant, which is making, 1.5 million tons of cement a year. But then you've got all these trucks and rail and sometimes ships going out to different ready mix plants and grinding stations and terminals. And so our view on scalability is this is a heavy industry, and the best way to scale is to go to the hub, not the spokes. And so that's been another key factor in our kind of philosophy, I suppose, is, with Ashgrove and with other partners like Cemex and others, we've really been looking at how can we integrate at the hub in a local supply chain, because that's where you can realize the most amount of impact with the least amount of supply chain disruption. And that's been a key factor that our partners have been kind of educating us on. We've really focused and tried to kind of take those messages on board.
I want to pick up on what you said about the local nature of the technology, because of course, one of the value propositions of cement and concrete is that it is a hyper local material. I mean, cement, you could say, is produced regionally, but concrete is absolutely a local product, usually within 100 to 150 kilometers at most from where it's being used in the economy.
Absolutely.
And in some ways, the increased reliance on supplementary materials like fly ash and slag kind of challenge that a little bit because, we're shutting down coal-fired power, we're moving to electric arc furnaces, and we might see sort of a change in the distribution of some of the traditional supplementary materials that we use. But carbon upcycling actually potentially provides a partial solution to that as well by qualifying new materials and making more out of the use of the materials that we do have access to. And I'm wondering if you could just touch a little bit on that, on the sort of local nature and how carbon upcycling supports that sort of local value proposition for the industry.
Yeah, Adam, absolutely. I think you're exactly right in that, the irony of kind of the cement decarbonization pathways is that as some of the other industries we interact with, whether it be coal power generation or just power generation generally or steel production, as these industries are decarbonizing and moving to more kind of environmentally friendly ways of producing energy or producing iron or steel, it's actually taking away a massive lever for the cement industry to decarbonize. And it's kind of, one of these things that you wouldn't necessarily expect at first glance, but as blast furnaces get replaced by electric arc furnaces, that staple SCM that most of Eastern Canada uses, much of the world uses, is getting less and less available and thus traveling further and further away. I mean, there are projects across Canada now where we've sourced blast furnace slag from Europe or from Asia, and that obviously is not in line with where we want to go. Same thing is happening with coal combustion ash out west. I mean, as I'm sure some of your listeners might be aware, as coal power plants are shutting down in Saskatchewan and in Alberta, in many cases, we're beginning to harvest some ash, which is great because that also is an environmental liability we need to take care of. And people like Doug Hooton, again, another kind of prominent Canadian who's doing, a really good amount of global work on this, is doing really, really good stuff in kind of moving that initiative forward in an aggressive way. But by and large, this issue of where do you get the raw material to blend into your cement is an issue. And I think what we have really focused on, Adam, even when I think of something like coal combustion ash, most cement companies and concrete companies have been using that coal ash for a long period of time, right? There's nothing really special about that. But what we have focused on is the subset of ashes that are currently suffering from chemical issues, reactivity issues, maybe LOI or loss on ignition kind of problems, and trying to upgrade these low quality deposits that otherwise would not really have ever been worth the hassle of trying to improve and upcycle. And so when we look at some of the recent work we've done on clays, on mine tailings, on coal combustion ashes that are generally low quality, I think these all strike us as being really interesting short-term solutions to start coupling, again, this circularity argument of taking waste from other industries that are local, maybe within that 100, 200 mile radius you were talking about, and then making that into a feedstock that we can cheaply source into the cement industry to then still meet our decarbonization targets without excessively increasing the price of the final product to the end user.
That's amazing. Yeah, thanks for that amazing answer, Apoorv. I want to sort of ground this now in actual projects. You mentioned you've got a 25,000 ton facility that's going to come online hopefully early next year with Ashgrove Cement, and wondering if you could tell us a little bit more about that specific project.
Absolutely, Adam. So Ashgrove's kind of parent company, CRH, is by market cap now the largest building materials company in the West. And they've been an active partner of carbon upcyclings for a long period of time, for over 3 or 4 years. And, we have other partners as well. We've been working with Cemex and Titan on projects outside of Canada. But within the Canadian context, Ashgrove had earmarked almost a couple of years ago the project in Mississauga, which, by cement production alone is the largest kind of cement plus slag production, would be the largest cement plant in the country. And our focus there is to prove almost exactly the point you just made about the locality of supply chains and the importance of that. So, there's a lot of steel producers around the Great Lakes region. Many of them produce steel slags, which are not the same as blast furnace slag. And most of the times, these materials are being crushed up and in some cases being used as aggregates, such as gravel in road construction projects. In other cases, they're just being used or not used, rather, and being kind of put into landfills or pits. And so what we've been working on with Ashgrove is to show that we can take this steel slag and create a partial substitution of clinker at that plant. And our thinking is that we've already done, multiple rounds of testing with our pilot facility here in Calgary, done a few rounds of testing with batches to show this material can become reactive enough to do 10, 20% substitution of this cement or clinker in the cement rather. And our thinking is that this will be a really interesting segue to show what does the collaboration between the steel and the cement industry look like in the 21st century. Because, up to now, for the last 50 years, whenever you had a blast furnace, you'd be able to sell that blast furnace slag to the local cement companies or the local concrete companies. And, that's something that's been baked in for over half a century. But as these furnaces are now switching to electric arc furnaces, that's that question. Like, can that relationship continue into the next 50 to 100 years? And our view is that with a technology like ours, we can actually continue to use those relationships that these steel and cement producers have had and actually leverage that well into the future. And, of course, there were some compromises that'll have to be made. A lot of people say that blast furnace is kind of the king of SCMs. It's basically the best cementitious material you can make. And much of that boils down to the chemistry of the iron ore and, what happens with that. But that is not to say that you can't come up with a good replacement for this. It might not be as good as blast furnace slag in many cases, but from an economic perspective, from a circularity perspective, domestic job creation, we believe that there's a huge amount of advantages without necessarily having to sacrifice on technical performance.
I love that sort of example of the integration of different industry or the evolving relationship of different industries, because one of the things that we've been trying to communicate is that, the cement industry is going through basically a historic innovation cycle right now. And a lot of that is being driven by the sustainability and decarbonization agenda. So, obviously it's super important to decarbonize, and we have a strong commitment to eliminating emissions from our industry. But the benefit of that has been ultimately this innovation cycle that it's thrown us into that is also a great economic story, a great productivity story, and in a way, also reshaping the types of collaborations that you've talked about with other sectors. And it makes me think about the future of climate policy, which it's not always understood in that perspective, right? It's not always understood that climate policy can actually be a real driver for economic innovation and productivity improvements. We all know productivity is a major challenge in the Canadian economy in particular. And, we're entering some pretty uncertain times, as I think, and our audience appreciates, both in Canada, but also in particular in the US, which is our largest trading partner. About 40% of cement production is exported into the United States. How are you guys navigating that uncertainty? And I'll ask about tariffs separately, but, in particular around the sort of policy landscape when it comes to climate.
Yeah, Adam, I would say, at this point, we're a small fish in the big pond. And so as a startup, we're obviously trying to do what we can within the purview of the different projects we're trying to pursue with our partners. But I would say notionally, one of the exciting things about the cement and concrete kind of perspective on decarbonization and the climate policy piece is how well it ties into the point that you made earlier about the hyper locality by design of the industry that we work in. And, in many cases, if you're trying to electrify vehicles, like I remember I was in San Francisco for a conference last April, and this was around the time that the Biden administration had put these 100% tariffs on EVs coming from China, right? That kind of a thing is almost impossible to do for the concrete sector. It's almost unnecessary because, to your point earlier, a lot of that concrete, the gravel, the sand, a lot of the trucks and everything is coming from the local economy anyway, right? And so in my kind of, from my vantage point, I would say cement has a cleaner story to tell on how we can achieve decarbonization and still help economic growth and economic activity in a much cleaner way than some of these other sectors because of the hyper-local nature of what we've got, right? Cement is probably the one angle where it does travel long distances if you're on, rail or on ship. But even in that case, there are ways of kind of localizing that production and internalizing some of the economic activity that's produced. And, I would say that as we look at navigating kind of, what the next few years look like, we're really focused on the supply chain piece almost as much as we have on the carbon emission reduction angle. Because when we go to a cement producer and they're needing to take, high grade clays that they need to import to then be able to calcine, and we say, look, you can actually do this with local shale that you already use in your kiln as your kiln feed. All of a sudden the economics of that work really well with what they're trying to drive from a climate perspective as well, because they're saying, well, we already own the quarry, we already have the supply chain set up, we don't have to spend extra money and kind of importing this material. Similarly, on mine tailings, on steel slags, even on low-grade combustion ashes, a lot of times there is a lot of synergy in what the coal power producer is trying to do and trying to, get rid of this environmental liability on their balance sheet. And if you're able to kind of make that capital kind of allocation argument to say, yes, you need to spend the capital to kind of build up plants like this, I think that's really the piece where we're hoping that working with the Cement Association of Canada and other kind of progressive industry associations, we want to get the message out to the policymakers that there is a huge amount of capital to be deployed in upcycling these resources locally to create local jobs, create economic activity, and internalize a lot of that while achieving the climate goals without needing to necessarily kind of make the mistakes that, policymakers have made in other industries. I mean, you look at, maybe it's not great to mention an example here, but hydrogen would be an example where maybe the focus on trying to kind of land some of these environmental targets kind of got ahead of where policy was and where maybe the public sentiment was. In this case here, I don't think that you really run that risk because you're still trying to do practically kind of pragmatic solutions that do make sense in the cost dynamic of the product that we're selling.
So do you see, you sound quite optimistic then, you see that our capacity to attract that international capital that you've mentioned about bringing investment into innovation and modernization towards technologies like yours, you see that as sort of an optimistic future as opposed to one that is called into question potentially by some of these policy changes and tariff changes?
I would say, Adam, I'm cautiously optimistic. I think, ultimately it depends, where Canada has, if I were to kind of sound a bit provocative perhaps, but I do think that Canada generally has shot itself in the foot a couple of times by not being ambitious enough. And, we've done a great job of incubating technologies and getting them up to a stage where, they're ready for kind of commercialization or prime time with commercial partners. But, you look at where we are now, outside of the Ash Grove plant, most of the projects that carbon upcycling is looking at right now are either in Europe or primarily in the US, despite what we're seeing with some of the pullback that the US government has done on some of the climate initiatives. And most of that is because they have prioritized domestic supply chains. They've prioritized, looking at capital expenditures and kind of incentivizing that for private players. And I think if Canada does the same, I absolutely think Canada can play a massive role, not just within kind of upstarting our own economy and kind of getting that going, but also creating examples that the rest of the world can follow. But I will say that there is an opportunity there. The track record suggests that maybe we won't take it, but hopefully that's different.
Where do you see carbon upcycling, say 5 years from now in 2030?
Yeah, it's something I think about a lot, Adam. I would say, just the 3 cement companies that are kind of invested in carbon upcycling, along with a couple others that are partnered with us. But if I just look at the 3 that have actually kind of invested and are actively looking at projects, between them, they own about 100 cement plants, right? Just over 100 cement plants over their global footprint. Our view is that if we get to a place where we've impacted 10 or 15 of those cement plants in the next 5 years, recognizing that the CapEx cycle for many of these plants is 2 to 3 years cycles, right? And of course, for a company at our size where we've got commercial demonstrations, but haven't quite done first of kind full scale commercial plants yet, there is this big kind of impending valley of death potentially of how do we finance these projects without over kind of embellishing the enterprise value of the company or kind of getting capital that can kind of hurt us in the future. If we can get the right type of financing to get these projects going, we absolutely think we could be affecting a dozen plants to help them reduce their emissions by 10, 15, 20%. And we do that, we think that we've then probably hit the tipping point to go in that phase from 2030 up to 2050 and actually make hopefully a double-digit impact in reducing the impact of carbon emissions across the industry.
I love the ambition. I love the optimism, Apoorv. Really appreciate that. And maybe on that note, to sort of tie it all together, what advice then do you have for entrepreneurs that are looking to get involved in the clean tech space, given the optimism, given the ambition, but given also what you've talked about in terms of the challenges, some anticipated, maybe many unexpected? What would you say to someone that's looking to get into the clean tech space today?
What I would say, Adam, and despite maybe my slightly negative sounding answer earlier, that if I knew what I knew 10 years ago, maybe I wouldn't have gone this way. I'm going to contradict that comment and say, I would say anybody who's thinking about what they want to do with their professional careers, I would just encourage them to get started, even if they don't quite have a full direction. One of the things that I've really begun to relish is meeting other kind of passionate individuals and people that are actually committed to this, and within their own boxes of what they can control are trying to drive change. I think, yourself and Sarah and the CSE team is an excellent example of this, right? Like, you get to meet people that are driven, you get to kind of work in a problem-solving mode where you're not necessarily working for the same parties, but you're working towards the same end goal. And I think that can create a lot of motivation, especially when times are tough or, you're having a tough week or anything like that. So, if I was to talk to someone who is looking to start another startup or look at kind of figuring out what to do, I would just say, you don't have to start your own venture necessarily, but there are many, many different ways to get involved in the ecosystem by joining policy think tanks, by joining associations, by joining startups, and really learning from the others that are also trying to problem solve real time. And I think, this is in my view, an excellent opportunity over the next 4 years, because there is so much political and kind of meta uncertainty around kind of how we're going to look at everything. And AI is the flavor of the day. But my thinking is that in 5 years from now, anyone who does choose to get involved in heavy industry decarbonization is going to look back and say, I made the right choice, because this is going to become more and more relevant. And you look at some of the things that are happening across the world with natural disasters. I just can't think of how you can potentially have more impact than starting to play the long game in industries like ours.
Apoorv, thank you so much for joining us today. I found your passion really inspiring, and I think our audience will as well. And of course, the technology itself is super fascinating. I really look forward to seeing how your success continues to grow in the future. And thank you also for the great partnership with the cement and concrete sector. Thanks again, Apoorv.
Thank you, Adam. Thanks for having me.
Thank you to our audience for listening. And don't forget to subscribe and follow our podcast on your favorite podcast platform. We hope to see you next time.